Chapter 1 Problems and Exercises. 1.2 Physical Quantities and Units. 1. The speed limit on some interstate highways is roughly 100 km per hour. A. What is this in meters per second? B. How many miles per hour is this? 2. A car is traveling at a speed of 33 meters per second. A. What is its speed in kilometers per hour? B. Is it exceeding the 90 km per hour speed limit? 3. Show that 1.0 meter per second equals 3.6 km per hour. Hint. Show the explicit steps involved in converting 1.0 meter per second equals 3.6 km per hour. 4. American football is played on a 100-yard long field, excluding the end zones. How long is the field in meters? Assume that 1 meter equals 3.281 feet. 5. Soccer fields vary in size. A large soccer field is 115 meters long and 85 meters wide. What are its dimensions in feet and inches? Assume that 1 meter equals 3.281 feet. 6. What is the height in meters of a person who is 6 feet 1.0 inch tall? Assume that 1 meter equals 39.37 inch. 7. Mount Everest, at 29,028 feet, is the tallest mountain on the Earth. What is its height in kilometers? Assume that 1 kilometer equals 3,281 feet. 8. The speed of sound is measured to be 342 meters per second on a certain day. What is this in kilometer per hour? 9. Tectonic plates are large segments of the Earth's crust that move slowly. Suppose that one such plate has an average speed of 4.0 centimeter per year. A. What distance does it move in 1 second at this speed? B. What is its speed in kilometers per million years? 10. A. Refer to Table 1.3 to determine the average distance between the Earth and the Sun. Then calculate the average speed of the Earth in its orbit in kilometers per second. B. What is this in meters per second? 1.3 Accuracy, Precision, and Significant Figures. Express your answers to problems in this section to the correct number of significant figures and proper units. 11. Suppose that your bathroom scale reads your mass as 65 kg with a 3% uncertainty. What is the uncertainty in your mass, in kilograms? 12. A good quality measuring tape can be off by 0.50 centimeter over a distance of 20 meter. What is its percent uncertainty? 13. A. A car speedometer has a 5.0% uncertainty. What is the range of possible speeds when it reads 90 km per hour? B. Convert this range to miles per hour. 1 kilometer equals 0.6214 miles. 14. An infant's pulse rate is measured to be 130 plus or minus 5 beats per minute. What is the percent uncertainty in this measurement? 15. A. Suppose that a person has an average heart rate of 72.0 beats per minute. How many beats do they have in 2.0 year? B. In 2.00 year? C. In 2.000 year? 16. A can contains 375 milliliter of soda. How much is left after 308 milliliter is removed? 17. State how many significant figures are proper in the results of the following calculations. A. 106.7 multiplied by 98.2, all divided by 46.210, multiplied by 1.01. B. 18.7, all squared. C. 1.60, multiplied by 10 to the power of negative 19, all multiplied by 3,712. 18. A. How many significant figures are in the numbers 99 and 100? B. If the uncertainty in each number is 1, what is the percent uncertainty in each? C. Which is a more meaningful way to express the accuracy of these two numbers, significant figures or percent uncertainties? 19. A. If your speedometer has an uncertainty of 2.0 km per hour at a speed of 90 km per hour, what is the percent uncertainty? B. If it has the same percent uncertainty when it reads 60 km per hour, what is the range of speeds you could be going? 20. A. A person's blood pressure is measured to be 120, plus or minus 2 mm Hg. What is its percent uncertainty? B. Assuming the same percent uncertainty, what is the uncertainty in a blood pressure measurement of 80 mm Hg? 21. A person measures their heart rate by counting the number of beats in 30 seconds. If 40 plus or minus 1 beats are counted in 30.0 plus or minus 0.5 second, what is the heart rate and its uncertainty in beats per minute? 22. What is the area of a circle 3.102 centimeter in diameter? 23. If a marathon runner averages 9.5 miles per hour, how long does it take him or her to run a 26.22 miles marathon? 24. A marathon runner completes a 42.188 kilometer course in 2 hours, 30 minutes, and 12 seconds. There is an uncertainty of 25 meters in the distance traveled and an uncertainty of 1 second in the elapsed time. A. Calculate the percent uncertainty in the distance. B. Calculate the uncertainty in the elapsed time. C. What is the average speed in meters per second? D. What is the uncertainty in the average speed? 25. The sides of a small rectangular box are measured to be 1.80 plus or minus 0.01 centimeter, 2.05 plus or minus 0.02 centimeter, and 3.1 plus or minus 0.1 centimeter long. Calculate its volume and uncertainty in cubic centimeters. 26. When non-metric units were used in the United Kingdom, a unit of mass called the pound mass, lb.m, was employed, where 1 lbm equals 0.4539 kilogram. A. If there is an uncertainty of 0.0001 kilogram in the pound mass unit, what is its percent uncertainty? B. Based on that percent uncertainty, what mass in pound mass has an uncertainty of 1 kilogram when converted to kilograms? 27. The length and width of a rectangular room are measured to be 3.955 plus or minus 0.005 meter, and 3.050 plus or minus 0.005 meter. Calculate the area of the room and its uncertainty in square meters. 28. A car engine moves a piston with a circular cross-section of 7.500 plus or minus 0.002 centimeter diameter, a distance of 3.250 plus or minus 0.001 centimeter to compress the gas in the cylinder. A. By what amount is the gas decreased in volume in cubic centimeters? B. Find the uncertainty in this volume. 1.4. Approximation. 29. How many heartbeats are there in a lifetime? 30. A generation is about 1/3 of a lifetime. Approximately how many generations have passed since the year AD? 31. How many times longer than the mean life of an extremely unstable atomic nucleus is the lifetime of a human? Hint. The lifetime of an unstable atomic nucleus is on the order of 10 to the power of negative 22 seconds. 32. Calculate the approximate number of atoms in a bacterium. Assume that the average mass of an atom in the bacterium is 10 times the mass of a hydrogen atom. Hint. The mass of a hydrogen atom is on the order of 10 to the power of negative 27 kilogram, and the mass of a bacterium is on the order of 10 to the power of negative 15 kilogram. Figure 1.26. This color-enhanced photo shows Salmonella typhimurium, red, attacking human cells. These bacteria are commonly known for causing foodborne illness. Can you estimate the number of atoms in each bacterium? Credit: Rocky Mountain Laboratories, NIAID, NIH. 33. Approximately how many atoms thick is a cell membrane, assuming all atoms there average about twice the size of a hydrogen atom? 34. A. What fraction of Earth's diameter is the greatest ocean depth? B. The greatest mountain height? 35. A. Calculate the number of cells in a hummingbird assuming the mass of an average cell is 10 times the mass of a bacterium. B. Making the same assumption, how many cells are there in a human? 36. Assuming one nerve impulse must end before another can begin, what is the maximum firing rate of a nerve in impulses per second?